Hello guys, in this video we are going to treat the overall cell cycle, the series of events that takes place in the cell cycle. But then the cell cycle is divided into two phases, interphase and the M phase or the mitotic phase. The interphase is divided into three phases, the G1 phase, the F phase and the G2 phase. The M phase is divided into 1, 2, 3, 4, 5 stages: the prophase, the metaphase, the anaphase, the telophase, and the cytokinesis. If you look very well, cytokinesis is not part of mitosis, but it is part of the M phase. So that's why I drew a line to separate cytokinesis and mitosis. What happened in the interphase? In interphase, the cell grow, nutrients accumulation, quantity control check, DNA check, transcription, translation occurs. But then we are going to treat each part independently. We're going to treat each part independently, starting from the G1 phase. What happened in the G1 phase? The intensive cellular synthesis, e.g. mitochondria and ribosome synthesis. This accumulation of nutrients that takes place in the G1 phase. And lastly, the cell growth that occur in the G1 phase. In the S phase, there's DNA replication that takes place. DNA replication. The DNA replication. The cellular synthesis of things like the mitochondria, ribosome, accumulation of nutrients, cellular synthesis, accumulation of nutrients, and lastly, growth occur in the S phase. This DNA synthesis and we call it histone synthesis. Histone. In the G2 phase, there's mitochondria and the chloroplast divide. In the mitochondria and the chloroplast divide, energy stored in form of ATP increases to prepare for the division of the other cell, and mitotic spindle begins to form. That's all about what happened in the interphase. We said in the interphase, in the G1, this growth, accumulation of nutrients, and intensive cell synthesis. In the F1 phase, DNA replication takes place here and histone. In the G2 phase, we said there's mitochondria and chloroplast that divide. Energy stored in the form of ATP increase and equal mitochondrial spindle beginning to form. In G2 phase, let us start with prophase. In the prophase, that is in mitosis. Mitosis is a continuous process which occurs in four phases, as we said: the prophase, the metaphase, the anaphase, and the telophase. In some books, you will see there's a pro-metaphase, but we'll put it in the metaphase, okay? In prophase, the prophase is the longest phase of nuclear division. In the prophase, the chromatide shorten, condensation of DNA protein coats at the end of the prophase. So at the the prophase reset, the chromatide shorten, there's condensation of gene echo, and the spindle fiber form. What happened at the metaphase? What will happen at the metaphase? At the metaphase, the chromatide attach to the spindle fiber and the centroma. The chromatide attached to the spindle fiber. Chromatide attached to the spindle fiber. The centroma line up across the equator of the cell, if we can say so. We have the centroma that line up across the equator. What happened at the anaphase? At the anaphase, it is very rapid. The centroma split into two. The centroma split into two. That's the first point. The centroma that split into two. The spindle fibers pull the daughter centroma to opposite poles. That's the second point that happened. The centroma pull the daughter at the spindle fiber pull the daughter centroma at opposite poles. The separate chromatide, now called chromosome, are pulled behind the centroma. That's another thing that happened. The separate chromatide, which are now called the chromosome, are pulled behind the centroma. Yeah, cool. The chromosome reach the poles and the vacuum becomes lengthened, losing its ability to be seen clearly. That's another point that happened in the anaphase. Oh, Jojo. No. Excuse me about at the telophase, the chromosome reach inside the pole and uncoil, become lengthened, lost the ability to be seen clearly. That's what happened at the telophase, not at the anaphase. That's the first point that happened at the telophase. The chromosome that loses losing its ability to be seen clearly. The spindle fiber disintegrates. The centroid replicates. And after the centroid have been replicated, the nuclear envelope will form around the chromosome at each pole. The nuclear envelope is reformed. Okay guys, that's what happened at the telophase. The chromosome lost its ability to be seen clearly. The spindle fiber disintegrate, the central replicate, and the nuclear envelope reform around the chromosome at each pole. And equally, we won't forget that the nuclei reappear. The nuclei reappear. The nuclei is returned back. The last step of the M phase, the mitotic phase, is cytokinesis, which is not a step of mitosis. It is a step on its own, just like I won't say it, but it is a step on its own. Okay, what happens in cytokinesis? In cytokinesis, there's equal distribution of organelles. All the organelles that were synthesized, the mitochondria, the ribosome, the DNA that replicated into two, they are being distributed into equal. So there's one part here that has mitochondrial DNA, and the other part mitochondrial DNA ribosome equally. So we divide it into two. What happens in animals? In the animal cell, there is constriction along the equator. That is in animals. There's constriction along the equator, and the constriction cuts the cell into two daughter cells. That's what happened